Hello everyone, welcome back to the channel. Today we're going to be expanding our topics and we're going to be starting to look at A-level computer science. This will be a revision video which is going to be covering the first bit of the OCR A-level computer science specification. However, the knowledge will be applicable to most exam boards in the A-level of computer science. In this video I'm going to be covering all of the components of a computer, and now let's get started with the CPU. Now there are several components that you guys need to know about, and those components are listed just here. So we need to know about the control units, the buses, the arithmetic and logic unit, and the dedicated registers. Let's have a look at them individually. Okay, first off, let's have a look at the control unit. Now, it's a very important part of the CPU. It controls and coordinates the activities within the CPU and is also directing the flow of data between the CPU and other devices. It will accept the next instruction, it will decode it into several sequential steps, such as finding the addresses from the data in the memory, and manages the execution of the data, storing back the resulting data that's been run into its memory registers. Okay, now let's have a look at buses. What exactly is a bus? A bus is a set of parallel wires connecting two or more components of a computer. It typically consists of 8, 16, 32, or 64 lines. The processor is actually connected to the main memory by 3 separate buses, as it has been shown on this figure just below. And when the CPU wishes to access a particular main memory location, it just sends this address to the memory on the address bus as shown down here. The data in that location is then returned to the CPU on the data bus just here. Control signals are sent along the control bus. In this figure, as you can see, the data, address, and the control buses connect the processor, memory, and the I/O controllers. These 3 buses are known collectively as the system bus. In fact, this is really important, so we're just going to write this down. The control bus, the data bus, and the address bus are known as the system bus. Each bus is a shared transmission medium, so that only one device can transmit along one bus at any one time. Notice how the data and the control signals travel in both directions between the processor, memory, and the I/O controllers. Addresses, on the other hand, travel only one way along the address bus. The processor sends the address of an instruction or of a data to be stored or retrieved to the memory and to an I/O controller. And just a little note that by the I/O controllers, what I mean is the input-output controllers. Okay, now let's have a look at each of the individual buses in greater detail. We're going to start off with the control bus. First off, it's a bidirectional bus, and this means that signals can be carried in both directions as indicated by those arrows. The purpose of the control bus is to transmit commands, timings, and specific status information between system components. Here are some sample control lines. For instance, you have a bus request, and that indicates that a device is requesting the use of the data bus. You could have a bus grant, indicating that the CPU has granted access to the data bus. You could also have memory write, which causes data on the data bus to be written into the address location. You could have an interrupt request, which indicates that a device is requesting access to the CPU. And of course, you have a clock, which is used to synchronize operations. Okay, up next is our data bus, which consists of 8, 16, 34, 64 separate lines, and once again provides a bidirectional path for moving data and instructions between system components. Okay, up next is the address bus. Just before we go into that, the memory is actually divided into units which are called words. A word is a fixed size group of digits. So normally 16, 32 or 64 bits, which is handled as a unit by the processor, and a different type of processors will have different word sizes. Each word has its own specific address in the memory. The address bus transmits the memory address of words that are used as operands in programming instructions. So when an instruction has been performed and the result is to be stored at a particular memory location, it is transmitted via the data bus. Okay guys, next one up that we need to revise is the arithmetic logic unit. The ALU performs arithmetic and logical operations on the data. For instance, it can perform instructions such as add, subtract, multiply, divide on fixed or floating point numbers. It can also perform shift operations, shifting bits to left or right within a register. It can carry out Boolean logic operations, comparing two values and using operations such as AND, or NOT, or exclusive OR. Okay guys, now let's have a look at registers. Now what are registers? So they are special memory cells that operate at very high speed, and all arithmetic, logical and shift operations take place in register. They're typically up to 16 general purpose registers within the CPU. Now some special purpose processors still use a single accumulator in order to simplify the design, and the accumulator takes the place of the general purpose registers. Assume all calculations take place in a single register called the accumulator. Now let's have a look at some special purpose registers. First off, we have the program counter, which is also known as the PC, and that holds the address of the next instruction which is to be executed. We also have the current instruction register, or the CIR, and that holds the current instruction being executed that is divided into the operand and the opcode. So let's do that. After that, we're going to be looking at the memory address register, the MAR, and the job of the MAR is to hold the address of the memory location from which the data is to be fetched or to which data is to be written. The memory data register, or the MDR, this is used to temporarily store data read or written to the memory. Now these will be a lot easier to remember once we look at the fetch, decode, execute cycle. Okay guys, so this was our first video in A-level computer science, and join us for our next video in which we're going to be looking at the fetch, decode, execute cycle. Thank you very much for watching, and I'll see you in the next video.